When you think of ridiculously fast trains, where does your mind go? Japan, right? With their sleek, punctual Shinkansen bullet trains that glide past Mount Fuji. Or perhaps China, a country building futuristic cities and infrastructure at a pace that is frankly bewildering. For decades, these two nations have been the poster children for high-speed rail, constantly pushing the boundaries of what is possible on a set of tracks. It's a battle of engineering giants, a technological race played out in miles per hour. So, you would be forgiven for assuming, quite logically, that the world record for the fastest train on wheels belongs to one of them. It seems like a dead cert, but you'd be completely and utterly wrong. The crown for the fastest conventional train doesn't reside in Asia. No, it belongs to the French. That's right, France. A country more famous for cheese, wine, and a certain degree of Gallic shrugging. Yet, on a crisp spring morning, back on April 3rd, 2007, they showed the world a thing or two about raw, unadulterated speed. On a stretch of track in the country's east, a specially prepared TGV, or Train à grande vitesse, did something truly magnificent. It didn't just nudge the existing record, it absolutely obliterated it, thundering along at a staggering 574.8 kilometers per hour. That speed, for those of us who think in proper imperial units, is a monumental 357.2 miles per hour. Let that sink in for a moment. That's faster than a Formula One car has ever gone in a race. It's the kind of speed that a small passenger plane reaches just after taking off. Imagine looking out of the window and seeing the French countryside whipping past you in a green and brown blur, the pylons and fences becoming a solid, continuous wall. This wasn't some lab experiment or a computer simulation. It was a real, physical train made of metal and glass, hurtling down a very real track. It was a spectacular statement of intent, a moment of pure engineering brilliance. This achievement wasn't just a fluke. It was the culmination of decades of French innovation. The TGV project began way back in the 1960s, around the same time Japan was pioneering its own bullet train. The French engineers were determined to create a network that would shrink their country, connecting Paris to cities like Lyon and Marseille in just a couple of hours. They succeeded brilliantly. The TGV has been a cornerstone of French life for over 40 years, carrying hundreds of millions of passengers safely and efficiently. But on that day in 2007, they proved that their creation wasn't just a practical people carrier. It was also a thoroughbred speed machine. Now, you don't just wake up one morning and decide to drive a train at 357 miles per hour. The record-breaking machine, codenamed V150, wasn't your average commuter train that you might hop on for a trip to Lyon. Oh no. This was a stripped-down, beefed-up monster, meticulously engineered for one purpose and one purpose only: to go faster than any wheeled train had ever gone before. The engineers at Alstom and the French National Rail Company, SNCF, took a standard TGV POS train set and began a transformation worthy of a superhero origin story. They started by making it shorter, reducing it to just 3 double-decker carriages sandwiched between 2 powerful locomotives. This shorter, lighter configuration was just the beginning of the modifications. The train was fitted with larger wheels than the standard TGV, which allowed them to rotate more slowly at extreme speeds, reducing stress and vibration. The aerodynamics were tweaked to make it slice through the air with even less resistance. But the real secret ingredient, as is so often the case when you want to achieve something spectacular, was simply more power. A lot more power. The engineers boosted the voltage running through the overhead lines from the standard 25,000 volts to an immense 31,000 volts, force-feeding the train's electric motors with an extra surge of electrical muscle. The track itself was given the same obsessive level of attention. The section of the brand new LGV S-line, chosen for the attempt, was prepared like a racetrack for a Grand Prix. The rails were strengthened, the ballast was perfectly graded, and the cant, or tilt, on the corners was increased to handle the stupendous forces that would be generated at such velocities. Every inch of the line was surveyed and manicured to ensure there were no imperfections that could upset the train. This was a symphony of engineering, where both the train and the track were tuned in perfect harmony to perform this one incredible feat. The result was a combined power output of over 25,000 horsepower. In the end, this was a moment of national pride, a glorious, chest-thumping display of what was possible. But it was also largely symbolic. Running a train at these speeds is incredibly stressful for both the machine and the track. The wear and tear is immense, and the energy consumption is astronomical. This is why commercial TGVs cruise at a much more sensible, yet still very rapid, 320 kilometers per hour, 200 miles per hour. The V150 project was about pushing the absolute limit of conventional wheel-on-rail technology, planting a flag so far into the territory of speed that it was unlikely anyone would ever have the reason or the budget to try and top it. So, if the French hold the record, what about all those stories of even faster trains in Japan and China? Well, that's where we enter a different world of train technology. The French TGV is the king of conventional trains, the kind that have wheels and roll on steel tracks, just as trains have done for 2 centuries. But the Japanese and Chinese are pioneering something else entirely, something that sounds like it's been lifted straight from a science fiction film: Maglev. The name itself is a portmanteau of magnetic levitation, and that is precisely what it does. It floats. It is, in essence, a train that doesn't touch the ground. The principle is brilliantly simple, even if the engineering is mind-bogglingly complex. Instead of wheels, a maglev train uses an array of powerful magnets. There are magnets on the underside of the train, and magnets embedded all along its dedicated guideway. By controlling the polarity of these magnets, making them either attract or repel each other, the system can do 2 amazing things. First, it can lift the entire train a few inches into the air, completely eliminating the friction between wheels and track. Second, by rapidly switching the magnetic fields along the guideway, it can create a magnetic wave that pushes and pulls the train forward at incredible speeds. This is why there's a debate about the fastest train record. In 2015, a Japanese SC Maglev L0 series test train hit a jaw-dropping 603 kilometers per hour, 375 miles per hour. That is significantly faster than the French TGV's record. However, purists argue that it's not a fair comparison. It's like comparing the world's fastest car to the world's fastest boat. They are both vehicles, but they operate on fundamentally different principles. The TGV's achievement is the absolute peak of wheel-on-rail technology, whereas the S-Maglev represents a completely different, and potentially much faster, branch of transport evolution. There is no metal-on-metal friction to hold a maglev back. The only things slowing a maglev train down are air resistance and gravity. In China, they are already operating the world's first commercial maglev service, whisking passengers to Shanghai's Pudong Airport at speeds of up to 431 kilometers per hour, 268 miles per hour. And they are even experimenting with a prototype train in a low-pressure tube, a sort of pre-hyperloop concept that has theoretically reached over 1,000 kilometers per hour, or 621 miles per hour, in a lab test. By removing most of the air, they remove the main obstacle, allowing for speeds that are simply impossible for any vehicle traveling through our normal atmosphere. This is where the future of ground transport is heading. The French TGV's 2007 record of 357.2 miles per hour is likely to stand for all time. It's not because it's impossible to build a wheeled train that could go faster. With enough power and a long enough track, you probably could. The reason is that there is simply no point. The V150 project proved that the absolute limit of the technology had been reached and, more importantly, surpassed for any practical application. The financial cost and the physical strain on the equipment required to beat it would be enormous, all for the sake of a little bit more bragging rights. The focus of global high-speed rail development has decisively shifted away from making wheels go faster and towards making them disappear altogether. The future, it seems, belongs to maglev. By eliminating friction, maglev trains are not only faster, but also quieter, and potentially more energy efficient at very high speeds. They offer a smoother ride and require less maintenance on their guideways compared to the constant wear and tear on conventional steel rails. Several countries, led by China, Japan, and South Korea, are already operating maglev systems and are investing billions in expanding them. What was once a futuristic dream showcased at world fairs is now becoming a practical reality, solving real-world transportation problems in some of the world's most densely populated regions. This doesn't mean the TGV, the Shinkansen, and other conventional high-speed trains are obsolete. Far from it. They are the workhorses of modern transport, forming the backbone of efficient national and international travel across Europe and Asia. They have an impeccable safety record and have proven to be a reliable and economically sound way to connect cities. The existing network is vast and well established, and it will continue to serve millions of passengers for decades to come. The TGV will always be a legend, a testament to what can be achieved with brilliant engineering and a healthy dose of ambition. But as we look toward the middle of the 21st century, the path forward is one of magnetic levitation. The dream of traveling between cities at near supersonic speeds without ever leaving the ground is slowly moving from the realm of fantasy to the drawing boards of engineers. The French TGV may forever hold the title of the fastest thing on wheels, a glorious champion from a bygone era of mechanical achievement. But the race for the future of travel will be fought in the silent, frictionless, floating world of Maglev. The next great speed record won't be set with a clatter of wheels, but with a whisper.